Hi, my name is Kieran McGrory and I'm working with Danny Pereira, and this is our Creating Solutions Lab.
Okay, so with the concept of concentration, it is the amount of solute dissolved in a certain amount of solution. So the amount of sugar or the amount of salt dissolved into solution, making it, in water. So salt water, sugar water, the more concentrated the solution is, the stronger the more concentrated, the stronger it is. So making the salt water very bitter and the sugar water very sweet.
The necessary steps to complete number 1 of the lab is you must measure 2.5 grams of salt in the weight scale, and then add enough water to make 100 milliliters in the volumetric flask.
So number 1 says, you are my TA and I need 100 milliliters or 0.350 m for molar salt solution, and I have salt for you. So with the concept of molarity over here, molarity equals mole of solute, which is in moles, divided by the volume of solution, which is always in liters. So when we go look at number 1, we take the 0.350 m, big M for molarity, equals X, which stands for the solute, over or divided by 0.1 liters. And by 0.1 liters, we got that by converting the 100 milliliters into liters. And how we did that was the ratio is 10 to the third, so 100 milliliters times 1 liter, which is what it's going to convert to, over 10 to the third milliliters. And after multiplying and dividing all of this, you get 0.1 liters. So you add that into the equation, and to find the rest of it, what you do is, all you have to do is multiply the 0.350 m by the 0.1 liter, and then you leave that to the side. Then what you do is you take the answer, which was 0.035 molar times 58.44, which is the molar mass of salt, the 22.99 plus 35.45 equals 58.54. So you take the 0.350 mole times 58.44 grams, because it's the molar mass, divided by the 1 mole. And after you multiply and divide all this, you get an answer of 2.0454 grams. And then you simplify it to 3 sig figs, which makes 2.05 grams.
To know the difference between whether to use molarity as in mole of solute over volume of solution, mole of solute over volume of solution is used for solid solutes, as in for M1V1 equals M2V2 is used for liquids. You can tell when it says stock solutions compared to tell you whether it's a solid solution or not. That's how you know. For solid and liquid solutes, to know the difference between which formula you use for each.
Okay, so number 2 says, you are still my TA, and I need to find 100 milliliters of a 0.350 m salt solution, but now I can only give you a 2.0 m stock solution of salt. Now, stock solution is a bit different from molarity. Stock solution is M1 times V1 equals M2 times V2. And in this equation, what we do is with M1 V1 and M2 V2, I noted that 2.0 is the first M1, so 2.0 M times V1, which is what we have to find, equals 0.350 M M2 times 100 milliliters, which is V2. And what we do is, after multiplying these two, we have 35 M slash milliliters which equals to 2.0 M times V1. We're going to divide 2.0 on both sides, isolating V1. So then V1 then equals 17.5 milliliters, and you then simplify that to 2 sig figs, which makes B1 equal 18 milliliters. So that's 18 milliliters of the 2.0 M solution. And to finish off the process of the lab, all you have to do is add enough water to make the final solution 100.0 milliliters up to the volumetric flask.
Number 2, you have to measure 18 milliliters of stock solution in a beaker and add enough water to get a final volume of 100 milliliters in the volumetric flask. And that's all you learn.